Hello, here I would like to show you my diesel heater install. Where we are currently is in a bathroom, and this recess part, apologies the light isn't great, was originally the rear door to the property. So someone's bricked it up or stoned it up. It's really thin. In fact, I don't know if you can see that part there. That's actually a log, as in wooden logs you would put on your fire. It was the same here and here, what looks like an old lintel. They'd put logs in the wall, so it's not been built very well. I thought, this is the thinnest part. The problem with this bathroom is condensation, dampness and mould. So I figured if I put it in here, we're going to have a couple of benefits. We're going to get rid of the water problem, the condensation. As you can see here, beautiful old walls, binder lath and plaster. So we're going to clean up the pointing, remove the lath and plaster obviously, clean up the pointing, expose the stonework. However, when it comes to the heater itself, what I've done, when the light adjusts again, is I've taken 22mm copper pipe, so your normal plumbing pipe, fitted compression fittings round. I've given it 2 channels. I've put a T-piece on where the exhaust comes in, so it's split. Now I may add a third here across the centre, another third bar, and again I may give it another outflow. As you can see, this is 2, so it's basically twin exhaust, but this reduces the exhaust pressure. You have a back pressure problem with these heaters when you run it through a long system, and she can coke up and things like that. But the other thing is, this is actually heating the stonework as well when it comes through. This helps deal with the condensation on the thinner part of the wall compared with the rest. Putting it behind, I mean there was already leaks in here, but putting it behind a plasterboard or lath and plaster in the thin point, you've got the temperature differential which causes condensation to form. So it didn't help. As you can see, when I've come through here, it's actually pushed some of the stone out. But if I can explain what I've done. So single exhaust input, 22mm copper, goes onto a twin output. It reduces exhaust pressure, so there's no risk of it clogging up the burn chamber due to inefficient oxygen, being able to get rid of it, the exhaust gases. The other thing is, down here, that's my air intake for the burner, that black module there. Now this is going to remove air from the room, put it through the burn cycle, which in turn ends up through this exhaust, well, radiator. That gets rid of some of the condensation and moisture from the room directly when we're having a shower, a bath, etc. And that's primarily when we'll be putting this unit on. Here is a blower intake. So I'm taking warm air from the room through the unit, and I'm outputting here. Now what's to happen is I'm putting a window seat, going to build a window seat into this aperture. I have an old Victorian style radiator to go to the front as well, so we can choose which we wish to use. So it's central water, central heating radiator. We run off kerosene, we're in the middle of nowhere, shall we say. But yeah, so that means I'm taking the warm room air, or whatever the temperature of the room air is, and I'm putting that through the heater, so you're getting a recycling process. If it was outside, it'd be having to heat air from, say, 0 degrees centigrade Celsius up to whatever your room temperature is. Well, if the room temperature is at 13 degrees, then obviously it's a lot easier to heat that air. So that's a big thing. That's removing condensation down there through the burn cycle. If you notice, the pipes are all angled downwards. So when the heat is coming in from the exhaust, she's evaporating off the moisture, and then it's basically being outflowed by the top, but they're all angled down anyway. There's a little drip feed on the bottom of the burner with the exhaust outside, just in case there is any residual fluids building up. But that pipe gets so hot you can't touch it, and so really that's not an issue. But the point being, this is to recycle as much heat as possible, to capture as much heat as possible, and add and removing condensation from there. I've heard comments about it creates negative pressure in your room, and so cold air must come in from somewhere to replace what's getting used. If you're doing this with the air intake for the burn cycle, I don't agree with that. Effectively, most houses, properties, bathrooms, etc. have fans, extraction fans. There's one in here. But it did mean a hole in the roof for the extraction fan. And I never fully close off either. And then again, if you look at a kitchen tends to have extractors for your cooker. And then very few houses are actually airtight anyway. So don't buy into that particular argument. You could also say that when we're running the shower, you're increasing the pressure in the room anyway because you're bringing a fluid in. So all in, for me, this is the best way I could possibly do it. That radiator gets so hot, extremely hot. The top, obviously not quite, but you still can't touch that. It's also going to heat up the wall itself, creating a thermal mass. On the back side of this, where the heater unit is, I'm going to box off the heater, insulate it, and the exhaust pipes themselves, what residual heat is left, I'm also going to try and focus and channel into something. But like I say, I may put a third pipe along here. I may just connect it into the top spar here, or I could outflow it if I feel I need to, but I don't feel that I do need any exhaust capacity. And the thing is, the next video I'll do is our up and running. I've got the entire system to sort it out outside, get all the fixings coupled properly, get the box belt, the cabinet should I say. We'll see where we go. But I think this has to be the most efficient method. Obviously we'll need a CO2 monitor in here just in case the exhaust leaks, but I don't see that ever being an issue with these type of connections. I check them periodically. Obviously we have expansion and contraction on them due to the running through heat cycles. But other than that, it all seems good. Right folks, thanks for watching the video. Take care, bye.